Hello everyone, welcome to my research presentation. I am Mobinul Hoque, and today I am presenting a conference paper of mine named Android-based heart rate monitoring and automating notification system. This was presented in 2017 IEEE Region 10 Humanitarian Technology Conference, that is R10HTC. In this paper, we actually proposed a device uh, which you should wear on your fingernail, and if your heart rate goes beyond a certain limit, a tolerable range, then our proposed device and Android app, we also made an Android app, sends SMS to some pre-selected persons. So this is the basic working algorithm. First BPM reading is taken, then it is BPM means actually beats per minute of heart rate, and then it is sent to the Android device by Bluetooth. Then we check if the BPM is in the tolerable range. If it's yes, then we keep doing what we were doing, and if it's not, then we wait for 10 seconds. We keep taking the BPM values, and if all of them are out of range, then we assume emergency condition and send the SMS. If all the values are not out of range, then we just go back and keep taking BPM values. For hardware, we used an IR pulse sensor, that is infrared pulse sensor. Uh, it actually uses infrared light to detect the blood flow on your fingertip, and it collects the photoplethysmogram signal, that is called PPG signal. Uh, and we also use the Bluetooth module to send the collected data from the IR pulse sensor to the Android app. Android, you must have an Android device, of course, to use the application. Okay, this is the algorithm for calculating the BPM heart rate, beats per minute heart rate. First, we take the analog reading of the PPG signal. We sample the signal at 500 hertz. Then uh, measure the peak and throw of the device, the throw of the signal, uh, and we calculate the IBI, that is interbit interval. We calculated it considering the 50% rise of the signal. So the 50% rise time between two successive rising is the interbit interval, and we followed some noise reduction protocols, and after calculating the 10 IBI values, where we averaged them to get the actual BPM values, and we resetted the previous PT values, that is peak and values, and we started everything all over again. So in summary, our device read the incoming BPM value. Then we, with our built device, built app, anyone can check his heart rate anytime, and if the heart rate is beyond the normal range, that is 60 to 140, then it will wait for 10 seconds, and then if all of the BPM values in these 10 seconds is out of the range, then it will assume an emergency condition, and it will start sending SMS to some of the pre-selected persons, and the SMS will contain the location coordinates. For that, we used GPS built in the phone and approximate location, uh, that may include road number, etc. So this is a screenshot of the graphical user interface of the app we created. Uh, it will be needing some phone numbers. We used three phone numbers, and of course it will have to be connected to the Bluetooth. uh, these were the test cases we presented in the conference. There were two test cases. One of them was at rest, and the other one had extensive exercises. We calculated their beats per minute value of heart rate using two methods. We calculated them directly from their wrist, and we used our device to calculate the BPM value, and we plotted them here, and we got a maximum error of 5%, so 95% accuracy was obtained. Uh, so this was good enough, and we uh, used this value, and so we use this value, and uh, whenever the heart rate was out of the range, we checked our app so that it sends SMS. That's it. So that's the end. This is my first research work. Uh, so thank you everyone for your patience.